It's Gadget UK here again. I know what you're thinking deja vu. This is the CPC we fixed previously, and you'd be mistaken because this is the CPC I fixed previously. It's a little bit dusty. This one belongs to Yellow Belly. He's got a YouTube channel. I'll post it down below. If you like Amstrad gameplays and things like that, it's worth checking his channel out. He also does a series called Retro Recollections where he interviews various interesting people. He had Novabug on there recently, and again, if you know anything about the Amstrad in terms of YouTube, you'll know that Novabug is a huge CPC fan channel. You know, he's got a lot of love for these systems and always does videos on them, on gameplays and things like that. He has a Saturday night game testing session, which is always fun to participate in, watch and, you know, guess how many games you think will be successful loading. Anyway, yeah, so this belongs to Yellow Belly. Thanks for sending this to me to have a look at. Without spoiling it, this is apparently going to be a gift to someone that Yellow Belly knows. So it's going to be quite cool to you know, for me to have a bit of an input into this in terms of trying to repair this so that it can go to that individual. So taped on top here we have some RAM chips. I think he's done some testing on this and come to the conclusion that the RAM was the problem, and I'm inclined to agree actually. I've done some quick tests on this, and it would seem to be the second bank of RAM, bank 1. You've got bank 0, which is the 64K that the standard CPC has, you know, the 464, and then you've got bank 1, which is an additional 64K. And just like in part 2 of my repair series here, and the one I looked at, it's got a Gotek. It's got a different display here. It's you know, a 7-segment, you know, 3-digit 7-segment display here. 2 buttons again. There's a hole there for something else. I'm not sure what that is, and obviously one for the LED. I've put my SanDisk Cruiser 32 gig USB stick in here because I've got lots of games and things on. One thing I have found, the firmware version on here seems to be incompatible with auto boot that I have. Auto boot, if you remember from part 2 there, there's a little media manager, you know, a file manager. So if you move to track 0, you've selected auto boot dot whatever it is in the root of the card there, and when it boots up it gives you a menu that allows you to navigate the USB file structure here and assign to, I think, 15 or 16 different virtual slots a disk image to each, and then when you switch it back on again you can use the buttons here to go between 1 and 15, I think it is, or 0 and 15 to select the particular game you want. So that file manager doesn't work with this version of Gotek. You could just get an older version probably of the auto boot and it would work okay, but nevertheless it works with the configuration from when I used this previously. So after having plugged this in, I noticed that the discs were exactly as I left them when I played with my 6128 there. I just can't run auto boot. So if we power on, I'm using the Amstrad MP1 power supply here, and I've got my RGB SCART cable connected. Let's just do a count. I'm not sure which disc that's got selected. Chase HQ. Now this is a very revealing one because I'll show you. Hang on, Chase HQ. If we load that, ironically this is the last thing I tested a minute ago, but it's turned out to be the most useful in terms of diagnosing this issue here. You can see the screen is loading okay there. Now when this game completely loads, it's the 128K version. Well, I say the 128K version. It's detecting there's 128K, so it's going to use all of that 128K. And it just so happens that with this particular game, the samples seem to get stored in bank 1 in the upper 64K block there. And that's key, as you'll hear, if you just listen to the sound. Whenever you get a sample played, it's all weird. And it sounds quite strange because obviously the data is scrambled. It takes quite a while to load. You can see though the drive LED is still there. So the game is loaded, and if I hit fire, got the joystick plugged in, just listen. Did you hear that? It was almost right. It sounded a bit garbagey, like there's some distortion. And again, we should get some speech here like go Mr. Driver or something. I can't remember exactly what it says. Did you hear that? So yeah, the samples are messed up. The game works fine. So I am pretty sure just from that test that it is RAM. It's interesting how the lower RAM is fine. All these, you know, all games that just use 64K, they work fine. It's only when you load 128K games you start to run into problems. But as I said before, it might not be the RAM, it could actually be the address decoding. There's a HAL on there, so it's a programmable device, a bit like a CPLD or a PAL or a GAL, and they use that for the address decoding there to switch between the banks, bank 0 and bank 1 with the RAM. I think they've both got a separate CAS signal by the looks of things from the schematics. So the thought I did have was it might be the RAM, might be the HAL, it could even just be a bad connection. Now, I've got some RAM test software. It doesn't really tell you exactly where the fault is. Let me show you, hang on. So this is the 128K version of Paperboy. So I think this bombs out, if memory serves. It's still loading. Yeah, there you go. That's what happened the last time I tested it, where it just blue screen, went back to, it reset basically. Hang on. Let's just see what's on that disk. Yeah, that's Outlaws. Now that worked for me before, so I'm not going to try that. Let's try something else. Yeah, this one works as far as I remember. But I suspect this is just using the initial bank 0, the first 64K. Yeah, no worries there. Everything looks and sounds normal, gameplay is normal. Oh. You can, whatever that one is, you can see that one just bombs. Just watch. It starts to load and then just resets. So yeah, that's the kind of behaviour I'm getting here. So here's that RAM test program. There are a number of different RAM test programs, so I'll perhaps show you some of them. This one says RAM expansion test found 64K. So it's looking at bank 1 here. You can see those red blocks. Now I've seen screenshots of this. When it works, when the RAM's okay, you get green blocks. So the interesting thing is, when I ran this the first time, it was like all this top row here were red. Now it's kind of like randomly distributed. So let's just press a key to repeat that. That is really weird. Because, well, the first thing I'm having issues trying to understand here. We've got 4 blocks, haven't we? Yeah? But then what are these down here? I presume these are the bank numbers, so it's like bank 0, 1, 2, 3, 4, 5, 5, 6, 7. Why have we got these 2 detected as banks here? That's what I don't get. Bear in mind initially it's found 64K, so it's not like it thinks some of these other banks are populated, yet somehow we've ended up with it showing these things here. Now that makes me think the address decoding is going wrong, which might be a problem with the HAL or something like that. The other thing you could consider are these bit numbers. Is it bit 0 bit through to bit 7? I don't think so. I think those are the banks actually, because this can go up to, I think, 512K. And that would make sense actually if you count the number of banks. You've got 64, 128K, so that would be 256K, which makes the second lot of 4 down here another 256K. So yeah, that's designed, that particular test is designed to test up to 8 64K banks. It's just really weird how we've got it showing these here. Maybe there's something wrong with the low RAM as well. There you go. That's what I had the first time. So it's just showing bank 0 as being faulty. Now I remembered this from watching one of Noel's videos, and that is the bank 1 is addressed in 16K blocks. You've got 4 16K segments, if you like, that it uses to address that upper 64K. So that is what these 4 blocks indicate. Actually, it's the 4 individual 16K blocks. Anyway, I think the next thing we'll do is tear it down and have a look at the board, just see what the board's like. And I might just go with the piggyback approach actually. I've got the new RAM chips here. Just piggyback one at a time, just to see if this test will show any other signs of life, if we can get some green blocks appearing. So after you've got the screws out, just lift it up and we'll just set the keyboard there. The screws that hold the side here, there was only one, and it's quite a long silver one. That's like a replacement, so someone's lost the screws for this, I think, at some point in the past. You can see the original cable sat on the inside there. That is not a good idea, because you can see it's just floating around in here. That could short on anything around here. So yeah, I'm tempted to connect that back up again actually, and I'll just stick something on there saying do not use. So you can see our RAM here, so I'm not sure which one of these is bank 0 and which one's bank 1. Now there are 8 of these, obviously because they're a single bit each, each one of them is a single data bit on the data bus, and it's an 8-bit system. You've got Z80, which is 8-bit. So if any one of these fails, all 4 of those blocks we saw there, the 4 segments, the 4 16K segments within bank 1, they're not going to work, and it's going to be the same with the main RAM, bank 0. You know, any one of those fails, the system's not going to work. None of the RAM will be addressable. Well, it's addressable, but you won't be able to, you know, if you write something or read something using those 8 data bits, if one of them's not working, one of them's missing, whatever you read and write is going to be messed up totally. So yeah, a problem on one kills the whole thing basically. This is the HAL. It's actually marked as a PAL on here. It's just a programmable part, you know, think of like PALs and CPLDs, GALs, etc. It's that sort of thing. It's some programmable logic, and Amstrad used this for the address decoding on the RAM there. So this is what switches between the base 64K, you know, bank 0, sorry, and bank 1, the expansion RAM, you know, the extra 64K. And as I talked about earlier, it's addressed in 4 16K blocks. So this is used to specify, you know, which of these is kind of in use. So that could be a fault, could be a RAM chip, could even be a trace. Now, the other thing I noticed looking at the schematics, the first thing is these are abbreviated on the schematics to a single block. It's like you've got a block for bank 0, a block for bank 1, and it shows all the data bits coming in and the RAS and CAS and all that sort of stuff. So, yeah, it's not that clear as to what goes where looking at the schematics, but you can certainly see where all the data bits go in general. But obviously here, it's not one chip, it's 8 of them. RAS and CAS signals come out of here, and there's a separate one for each, sorry, the CAS signals in particular, there's a separate CAS signal for bank 0 and bank 1. Now I'm pointing to this side here as 0 and this side as 1. That might not be the case. It might be this is 0 and this side here is 1. So I'm not sure which the upper 128K is. I'm going to assume, since the Z80's, well, it's not, you can't go off that. Let's just assume that this is the expansion RAM here. I'm going to start by piggybacking these one at a time. I'll run that RAM test and just see if we get any further. Ideally, you'd want to run some memory test software that is capable of, you know, writing to an address, reading back, and then showing you the problem with the bit pattern. You know, i.e. it might be bit 3. You've got a problem with bit 3. If we knew it was bit 3, I could literally just test follow whichever one of these here is data bit 3 through its buffer. There's probably going to be a buffer or something somewhere, to the Z80, and then work out from there exactly which chip it is. But I can't find any software to do that, and I just can't be bothered messing around with BASIC to try and write something myself. I think Noel said he was going to have a go at writing some diagnostic software himself, so yeah, keep an eye out on his channel. I'll post a link down below again. He may get around to that at some point in future, and that would be super useful. So we found our first clue there. Can you see some corrosion on that pin? So maybe this chip here, and it could even be corrosion's got on there and damaged the trace. I don't know. Let's just try cleaning up that there, because what I was trying to do is piggyback, and I got down this far here to this chip, then noticed that. So obviously the piggyback's not going to make a good connection there. So if we just clean the tops of those there, and then the piggyback will make a good connection, just in case that RAM chip is the issue. But we will perhaps remove that and have a look underneath there. Well, would you believe it? After 2 minutes, literally, I've fixed it. I know exactly which chip it is. Let's just try that again, just for good luck. So yeah, on this occasion, the piggyback method has made this super easy. Anyone can do it. There you go, look. It's taking its time, look, on each block. Yeah, that's it, fixed it. So it wasn't this one with a corrosion here, it was this. After we finished this bank here, started here, as soon as we got here, that's it, started working. And if I take that back off, you get the red blocks straight away. Put that piggyback on there, and as you saw, it flashes grey, 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 green, and moves to the next one, grey, 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 green, and just works its way along. So it really is as simple as desoldering that chip, putting a socket on, and fitting that chip. So let's get this unscrewed here, get it over to the mat, and we'll swap that. Right, so we're on the mat here. I've got my ESD wrist strap on. Someone raised an interesting point about that recently, actually. If you're right-handed, wear an ESD wrist strap on your right hand. Certainly if you're dealing with anything where there's a chance you may get an electric shock. Because if I was to get an electric shock now, it's going to go up my right arm, through my chest, right through my heart, down my left hand, into the wrist strap, and, you know, into earth there. So just bear that in mind. But when you're dealing with stuff like this here, you know, I'm not going to get a lethal electric shock off this. The purpose of the wrist strap here is to just pull an ESD, you know, static electricity, to ground, because it can be thousands of volts, you know, like 5,000 volts or more, 10,000 volts. You can actually build up an ESD charge, and you touch an IC, zap, you damage it. And this is somebody else's board, so yeah, I'm just being extra careful with this. I want to get it back in one piece. So the ideal way to remove a chip like this is with a desolder gun. I've covered this on my channel before. I'll stick a link up there to it. That's not screwed on very well, but you can see it's not on. I wouldn't touch that when it was on, certainly not. I just want to show you using a standard soldering iron and a desolder pump, because that's the thing that most people will be able to easily get without a lot of cost. I mean, a desolder station is only going to set you back about £70 or £80 probably, so it's this one here we're targeting, I think. Yeah, so nevertheless, that's one of the reasons why I will show in lots of these videos here me just using a solder pump. So to start with, I'm just going to go over these and heat with some fresh solder and flux, and just make it a bit easier to remove. This solder contains flux, by the way. You could add your own dedicated flux. It'd be interesting to see how easy this comes off just using the solder pump, actually. I'll show you the solder pump in a minute. The solder pump actually came from Andrew Littleboy, and the Hayco soldering iron came from Dermot Sweeney. So it's another community repair. We're repairing something that's going to be given away as a gift to somebody else. Yeah, you can see the print on it's pretty warm there, because I've used it a fair bit actually. It's a nice pump. I'm going to start with the pins away from the corners, because they're like bent over. You can straighten them out in a minute. Just heat for a few seconds till it goes molten. You can see we've got a nice little gap around that pin there. Sometimes just pressing into the pin a little bit can help, but hopefully this should be super light work, certainly with the engineer pump here. This is where a little bit of flux may help, or just crank up your soldering iron another 10 degrees or something. Yeah, so with a little bit of additional heat there, that has sunblocked pretty much. There we go, got it. So let's just use a brush there. Yeah, flipping the board over here, so we can see we've got a couple of blobs of solder there. What's unfortunate here is we're right next to this serial number, aren't we? So this is probably going to have to come off, because I can't really see what is going on down there. I can lift it a little bit, just try and get under it. Yeah, that's going to have to come off, I think. Stick it back down, just try and get it off without tearing it. And it's coming off a little bit there. Yeah, can you see we've still got quite a bit of solder here? It's actually leaked upwards onto the legs there. Anyway, let's just do my usual trick here. So the trick here is to grab 2 or 3 pins and just pivot a little bit like that. If they're totally free, you may hear a snapping sound as the solder snaps off the edge, but in this case I don't think they are. I think they're still kind of attached on the top side. So where you've got lots of solder like that, what you could do is just add a bit of flux, as I've done there, and heat actually from the top side here, just where the additional solder is. And then the braid should mop up that bit of solder. Can you see that? There was a big blob on there, that's gone. We'll do the same on that one there. As I say, the main reason to show you these things is to show you different ways of doing things. It would be far too easy for me to just use the desolder station there and within 10 seconds remove the chip, when many people, perhaps when you're starting off wanting to repair things yourself, you might not have that kit. There we go, so got a bit of the solder off on both sides there now. Let's just have another go with this. There you go, looks starting to snap off, look now. Hear that? In theory I could cut this chip, that's the other thing. You want quick techniques, you could just snip the pins from the top side. That would make it super easy. I might even do that actually. Because if I'm struggling with this, why struggle when you could just chop it off when you know exactly which one's faulty? There is no mileage in carefully removing it. Now the other technique I was shown by engineers back in the day is to leave it into the pin here on the top side. Certainly if you know you're taking it off, if this chip is definitely going to be, I'm being careful here because I can see it's loose already, can you see it starting to lift on one side? If you know the chip is definitely not going back on, it's definitely faulty, and this one is, what is the point in being careful with the actual chip itself? All we are interested in here is the PCB, so yeah, just by virtue of pressing into the pin there, you can snap them off the edge. I don't think I've shown this technique properly before, but as I say, that's exactly where I learned, that's where I started. One of the first things I was shown in terms of desoldering chips was to push into them here, like this. If you've got rid of most of the solder, let's just pull that off. I can stick that serial number back down. There we go. I think we're there, because it's kind of moving in all orientations. So if we just get under here like this, can you see that? It's coming up, look. And I'm not having to lever it very much. If you got the screwdriver under there and it wasn't just moving on its own like that is, you know you've not got enough of the solder off. So hopefully won't lose a pad. We may do. You know, doing something like this is where you risk losing pads. If you use a desolder station, that isn't going to happen. It's just kind of seesawing in the middle there, but I do think it's off. Let's see if we can get that under there. Yeah, look. Yeah, there we go. No damage. No damage, as you can see. And our chip is off. But as I said, you could just bring your cutters in. You know, if we were removing that one now, I could go snip, 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 all the way around there. You've got the pins left, and you can just use, you know, tweezers there. And then you could just, you know, grab the pin, heat from the other side, pull it out nice and carefully. In any case, there we go, socket on next. What I'd like to do is swap the banks around. I'm not sure how easy that is to do. Might be able to do it with a wire, I'm not sure, I'll have a think. If we swap the CAS signal, we may be able to swap the banks, because that would allow us to flip these around, run that RAM test. The RAM test is testing the upper bank, but it will then be testing what was the lower bank, which is now the upper bank, if that makes sense. And that would just give us some confidence that all of the RAM is okay. So I'll see if I can work out how to do that. It might just be a case of pulling the hull out, bending a couple of legs temporarily out of place, and have a couple of wires somewhere to flip the wires around maybe. That would perhaps work. So I've got on my sockets here. You can see this is how I store sockets. It makes sense, because you can fit quite a lot of them in a drawer, and they're not, you know, the pins don't get bent and stuff. Plus, when you store them like that, you know exactly how many you've got, because it's easy to count them that way. So pin 1 is to the left hand side here. There's a little dot in the left hand side of each of these chips here. So if we get our socket on there, may have to just remove a little bit of solder. Yeah, I think 1 or 2 of these pins here perhaps just need a touch more solder removing. Just makes the socket go on a bit easier, doesn't it? Let's just wipe over that again, because it's going to be covered up by the socket, isn't it? And if we try and get the socket on now, yeah, there we go, it's gone straight in. Solder a couple of diagonal points here. We'll do that one and that one, and then just flip it back over, make sure it's flat, which it is. Now I'm really fussy about things like this. I don't know if you can see, it's nearer to here than it is here, there to there. Does that make sense? So I need to pull this corner down a little bit. So yeah, it's quite pedantic. It's a really minor thing about presentation, I guess. Yeah, that's not too bad. I could do with a little bit more still. And this side here just needs moving down a little bit now, I think. There we go, I think that's pretty straight. Now, funnily enough, a RAM repair like this was my introduction to the CPC, actually. First time I got to use a CPC was a RAM repair on a 464. Now, the clue on that one, and I didn't talk about it, temperature. Just felt the tops of the chips there. It wasn't booting at all, that one. I think it was given a blue screen or something. There was no text or anything coming up, and yeah, it was RAM again, but it was just getting hot, so it was dead easy to diagnose that one. I'll typically touch these pins a couple of times just to reflow the solder. You know, you get an equal size solder point. I'll remove the solder from the tip and then just literally touch each one a couple of times like that, and they will kind of equal in size. Again, it's just cosmetic. You don't have to really worry about this sort of stuff. As long as nothing's bridging where it shouldn't be doing, it doesn't really matter the size of the solder blob. But you might be able to tell from there, yeah, they're all equal. There's obviously more solder on this than there are on these, but it's not a problem. So let's get a cotton bud with some IPA. We'll clean that up and we'll stick a RAM chip in and go and test it, and hopefully we'll have nailed it. The other thing you can do is just mask off the wider area of the board, because when you start to scrub this, it flicks all over the place, and then you end up having to clean more of the board, if that makes sense. It's better to kind of just localise all the splashes. While we're on the subject of Noel as well, an interesting tip that he showed on his channel. I'm sorry, I feel like I'm stealing all his tips at the moment. Hang on, let's watch his channel. His channel's really good. Hang on. Yeah, one thing he does, I've seen him do this, and someone said, why don't you do that? Now, I've done it. It doesn't always work very well for me, I found. Is what you can do is, you know, you clean an area like that, and then when you want to dry it, stick the toothbrush there and do that. That's one of the things he does. And that seems to work well where he does it, but yeah, you can see that, it's not too bad. I prefer, to be honest, to brush it like that, and then use my dry brush, and you will find you don't get any streaks or anything. Just brush it until there's nothing left there. As you can see, that looks pretty good. So the board is loosely positioned. I've just grounded myself before touching this, and then we'll just get the chip into the socket there. Now, I didn't show disconnecting all this stuff, but it's pretty obvious. You've got a blue connector here that goes to a blue connector on the board there, 2 pins, so you can just slide it back on. And there's a white one here that goes just behind there that you can't see. And then if we carefully move the keyboard over here, you can see we've got these 2 flex ribbons. So let's do the outer one first. Just hold it and go straight down, nice and carefully, and then do the same thing with this one. Bear in mind, it's easier if the keyboard is sort of that way a little bit, because they're bent outwards. There we go, that's back in. And if we connect up our video and our power, and it should have remembered what disc we're on, the memory test. Why is that not working? Cats, it's a bad command. How is that a bad command? So I had a really weird issue there where it was saying cat is a bad command, and I just reseated the drive, screwed the board in, and it seems okay. So let's do, what am I doing, run disk? Run RAM test. So I'm not sure if there's a bad connection somewhere, if there's still some sort of issue with this, but you can see that that has nailed the RAM issue in the upper RAM. It does make me wonder if the lower RAM's got an issue. Maybe that's what that cat's bad command was. And if I switch it on without a RAM chip in, you'll see we get a grey screen there. Right, so I'm going to have a go at swapping those banks around. Now, I'm not sure this is something that is done. I've not seen anything anywhere on the internet. Now, Noel did a very similar video. I'll post a link down to that below. I think in that case, it was to revert it to a 64K machine, I think. I could be wrong. It's not the same, because this is just, all I'm going to do here is swap 2 pins around. So the pins we're dealing with for the 2 CAS signals are pins 6 and 7. I did make a mistake actually, I'm going to redo this. So 1, 2, 3, 4, 5, 6. Yeah, that's 6. So this is the adapter I've just made, and I'm going to take it to pieces. Now you can see I've got the pin 1 notch here. This is actually wrong. This was a mistake. But I'll talk about that later. Basically, being able to rotate this around doesn't really matter. If you imagine the left-hand side here is pin 1 on the socket, and I've got 2 sockets. If I just separate these 2 sockets, all will become clear. It's very, very simple. And I just carefully pull them apart. So, as I say, you got your pin 1 here, yeah. So pins 16 and 17 here, all we're doing is swapping them around. So I've got a wire soldered to each of the ones on the bottom socket. There's a bit of tape that was there just to isolate the pins above. I folded the pins above, the same 2 pins there, folded them out, and literally pulled, a wire from 16, soldered it to 17, and 17 to 16. Does that make sense? Let's just check that. 20, 19, 18, yeah, 17 and 16. So pin 16 goes to 17 on here, and pin 17 on here goes to pin 16 on there. And as I say, when you've done that, then just put a bit of tape over the white legs you've got folded up there, the bent over, the bent out here at 90 degrees, those 2 legs, with the wires onto them, and then you can just like push the wires into the socket. Make sure you don't get trapped between the pins there, and just join it up like that. You can at that point then just test on your multimeter to make sure that when you get to, well, make sure all the things are passing. So that should go to that, that should go to that, that should go to that. As soon as you get to these 2 here, this pin here goes to that one, and this one goes to that one. They're flipped around. Dead simple. Right, so my little tower of insanity, it does actually work here. What I had to do though is flip it around. Looking at the schematics, the pin numbering meant that you skipped 3 here, and then it was these 2 here that needed swapping. Now that's wrong, the pin numbering's wrong. I'll show you the diagram. It's like it goes 1 to 9 on one side and then 1 to 9 on the other, and you're like, what's going on there? What's the actual pin number? It's got the VCC and the ground pin numbers correct. It's like missed a digit off the ones on the other side. So anyway, I just rotated the socket the other way around. So you've got 3 pins up here, and then the 4th and the 5th here are flipped. Yeah, if that makes sense. And I confirmed this. I thought, what is going on here? And before I worked that out, I went from the CAS pins on these. Pin 15, that's one of them. If I go up here, it's going to be 1, there you go, it's that one, it's the 5th one. And from the other bank over here, it's not the 5th one, it's the 4th one. So if you measured normally there with the HAL straight in, you'd find the opposite of what I have now. They are actually swapped. And as I mentioned earlier, there's a video on Noel's Retro Lab that shows a similar mod but with 5 wires. It's a bit different, and it seems to be swapping them around but disabling. You've only got 1 bank, I think. So that's what we're doing. Run disk, there's no disk, run RAM test. And the reason that 5 wire mod exists is for those cartridge, Diagnostics cartridge, so you can test the first 64K, because it's the opposite problem we've got here. I've been trying to focus, in fact all the tests I've got here, most of them seem to focus on the expansion RAM. I need to test the lower 64K of RAM. If you get a Diagnostics card, those just test the 64K on board, the base RAM, the bank 0, if you like. So the problem with that is when you want to test the upper RAM, that's the difficulty. So that's the little mod board that Noel covered in his video there, which allows you to just focus on testing the lower RAM, by swapping the upper into the lower, but you don't swap them around completely. You end up with 64K. As far as I can see, it's totally different how that mod works. All we've done here is swap the CAS signals, and I'll show you on the schematics. That is the only difference between the banks, the two banks of RAM. The pins are all pretty much joined up in parallel, apart from those CAS signals. But I'm confident now, because that's given us a good bill of health there. That RAM looks okay, and I can repeat this a number of times just to be sure. The lower 64K of RAM is good. even though it says expansion RAM there, we are actually testing the physically, you know, the lower block on the board. As soon as I remove that little socket, we'll be testing the expansion RAM again when we repeat that test. So I think I'm going to clean up the board next. We'll take this back over to the mat, clean up the board with cotton buds and stuff. I can obviously swap that back now as well. But I'm going to check some of these caps here. So I covered a lot of the same stuff in the previous repair. I'll stick a link up there. And I'll just continue cleaning around this now. I've done the connectors there on the top and bottom side, you know, the edge connectors. You can see how dirty this is though. Look at the cotton bud. It's black. So I spent about 20 minutes on the top side of the board. There's a few more bits to do in between the connectors and things back here, but hopefully you can see that's looking a lot cleaner. So I may as well just finish off here, because there are a few bits around these caps and components here, and we'll clean the ribbon cable up as well, I think. Let's just give this bit here another go. So contact clean it into the switch, and a little bit of that, and again a little bit into the volume pot, and just do a bit of that. Solder points on the ports are good. I've inspected those on all the ports, you know, the joystick port, power, AV, etc. We'll just have a clean in there anyway. So I've got some contact cleaner in there. I'm just going to go stick the power connector in and out a good dozen times, and that should ensure that that's a good connection as well. But the solder points are good on these. Actually, I am going to reflow the power connector here. Can you see it's knocked to the side a little bit? So yeah, it's probably just from being knocked in the past, you know, and it's obviously been used a lot over the years. So we'll just add a bit of fresh solder and flux. I might need to increase the temp on the iron here. It has literally just been switched on, so yeah, let's bump that up. Just increased it by about 40 degrees there actually, because that is just not melting, and it's because there's such a large piece of copper here, you know. There we go, that's melting now. We'll remove that. We'll stick fresh on, but that'll just help me move this in a second. Let's just add a little bit more there and then get it off. Yeah, there we go, you can see. Remove that. I'm using leaded solder here, by the way, which is what you want for rework. You can't use leaded solder in new stuff. I may have mentioned that on a few videos now, but yeah, you've got to be ROHS compliant and all that stuff, so on new products and things, but for servicing old stuff like this you can use it apparently. Right, let's just add some fresh solder. Final point. Of course, you get better thermal transfer here with a bigger tip. I've got a really fine point here. That's the reason why I've had to crank the temperature up. Just add a tiny little bit more there. There we go. I'll just clean that up. There we go. Should live to see another day. I'm not doing a full restore on this because obviously it's not mine. I could spend, you know, I've spent insane time already. It didn't take long to fix the RAM, but in some of all the clean-up work, yeah, I've spent an incredible amount of time today just cleaning up the PCB and now cleaning in here. So let's get these things back up here. Managed to just reroute these a little bit. Got the hair there, look. Let's just get that back into there. Is that the wrong way up? I can't remember which way around that went now, actually. Yeah, it's on towards this port here, so we can actually just test that. If I just make sure nothing's short and it isn't, let's just connect the power up there. And just connect video as well. switch it on. Yeah, that's the wrong way around actually, because it's on towards the thing there, so I did have it the right way up to start with. So that's that. Best way to get this in is to put it in the front here and then push it down to this little clip once you get it into the right spot, like that. That's that. Get these motherboard screws back in, they're the shorter ones. I think it had a full complement of the motherboard screws actually. To be fair, there aren't that many, they're all marked with a little white arrow. So he also kindly included these things actually, a copy of Robocop. The box has seen better days, but I can always just bend that into place and clean it a little. It's got the original instruction manual there, and I've forgotten about this, they came with a sticker, a giant sticker. Wow, I do remember that now. And it's the disc version. Game Tech tested and approved. Very cool. I really wanted a copy of that. Along with, I wouldn't mind Operation Wolf at some point, Xenophobe. I tried to buy Xenophobe for the CPC, and if you saw my previous 6128 video there, when I fitted the Gotek, I was talking about the price of the games. When I looked at Xenophobe, it went for £90. £90 for a floppy disk. You've got to be kidding me. So yeah, unfortunately I couldn't bid on that one. It was too high. It did sell at that though. So anyway, thanks very much for that, mate. It is really nice to own a copy of Robocop. And of course he let me keep the old drive as well that was removed from this. Now he did say he's replaced the belts. I've had a look at this. The belts is on there, so he's definitely swapped the belts. And I think he said he'd lost the right protect pin. So yeah, it needs a new pin. Now I did briefly test this drive. It just red lights all the time. Now it should be slightly dim and then it should go bright when accessed, but this seems to be on all the time, which would indicate a problem with the logic on here. It might not necessarily be that. There are some little transistors and stuff on here. I'm not sure you can see them from this side. So anyway, I will have a look at that in another video, but I can't imagine I'm going to be able to fix that perhaps without a new custom chip on there. It might even just be the solder's bad. Can you see that? It looks terrible. Yeah, I think it's going to be fine. But if there was ever another fault with this, I don't mind looking at it again. It's not a problem at all, you know. With things like this, you know, I've not charged any time for this, and if the person he gives this to has a problem 2 years down the line, I don't mind looking at it again, and it'll just be shipping, you know, literally. No problems at all, because it's allowed me to keep the spare chips here. You could argue it's beneficial to swap all the chips, but if you're going to swap the ones in this bank, you may as well swap all those as well. You know, where do you draw the line? I've seen lots of faults like this over the decades where it generally is just one chip. You replace one chip and then it can run for, you know, another 10 years without an issue. If you're super unlucky, another one fails and another one fails, but that is unlikely. It's very far and few between that happens. The other scenario is where when you get a failure, you don't just get one failure, you get 4 or 5 failures. I've had that on Amiga boards where the same make, actually, these Kyocera ones I think they are, you don't just get one faulty, you find out of a bank of 16 like that, you might find 5 or 6 faulty all at the same time. And you can generally just swap those 5 or 6 and then it runs alright forever. Well, not forever, but you know, for a very long period of time. Anyway, I've spent enough time on this, I think. As things stand, it's all been cleaned up. It's fully working, so we'll just get the lid back on and have a bit of a play with it. Just cleaning around the top of this now. You can see it is pretty dirty. Just get a little bit of plastics onto that scratch there. This piece here is not going to go off, I think it's a really bad scratch, but the bottom bit here is really superficial. We'll wipe the whole bottom of that actually, and overwrite it. So the keyboard's had a good wipe over as well. Let's just get a little bit of silicone on there. I don't get any of this silicone in this tin left actually, need to buy some more. I nearly forgot that serial number, so I've just stuck that down with a little bit of rubbery glue. It's like Yoo-hoo. So you can just about see the number there. It's 34822 9535. I think that's a 9. Anyway, I'll get the lid back on. So this game would not run at all previously. As soon as you started the load, I think I might have showed it actually, Pinball Dreams, this would reset here instantly. and now we get a black screen, we get this message. So there we go, just a bit of evidence that it is actually working. Sweet. You may notice it looks a bit flickery here. It's just the way this TV handles an interlaced signal. They've used interlacing there to get more colours probably, and you know, it just looks high resolution and stuff. Well, higher resolution than you typically get. It's an amazing port, this, it really is. So press F1. Yeah, same keys, F1 to start a game, down arrow to pull the plunger back. It's not the right shift, it's the right enter. That got me. I'm just going to test that right shift just to make sure it is working. So cool. It plays so much just like the Amiga one, you know, the physics, it just feels almost identical. So our samples should be correct on Chase HQ now. Let's just plug the joystick in and then we can hit fire. Let's see what it sounds like. Yeah, that's normal. Yeah, don't know if you heard that. Hold on, man, it was a bit quiet. Changed gear a bit soon there, but anyway, that is now fine. Let's try Paperboy again, because that wasn't working. So this would reset the machine, I think, after a few seconds. Yeah, there we go. So that is working as well now. 2, joystick. 5. Yeah, that's working as well now. Oh my god, that's unfair. Now, Target Renegade would allow you to define the keys, and then as soon as you start the game, that's when it would bomb. So we've got just as far as before. Let's define the keys. Left, right, down, up, fire. Left, right, down, up, fire. Pause. And if we hit one player, yeah, this is where that would have just frozen down, that white screen. It's actually loaded now. The right shift works, by the way. Tested that. If you want to know more about the 6128 and the 464, check out the previous repair videos. I'll stick a link up here for those. There was a 464 and a couple on the 6128 here, including fitting the Gotek and doing some stuff with the floppy drive and what have you. So as I mentioned earlier, the RAM is kind of abbreviated into one block for each bank like that, whereas actually you've got, as you saw on the board, 8 chips for each bank. So yeah, that's the first thing that's different versus this schematic, and it may well be this is from a later one. Maybe there's some, I don't think so, it says 8 of there. That says 8 of as well, so anyway. If I zoom in, so a little bit closer there, you might just be able to read this text. It says separate CAS to each bank. Otherwise, second bank is, I think that it's been cut off there, it says it's in parallel. So in other words, every single connection on these are in parallel on the RAM. So all 16 modules, all of the connections are in parallel. Obviously, apart from the data bits are separate because they are, you know, each chip holds a separate data bit. The only other difference is these CAS signals here. You've got CAS 1 there and CAS 0 there. So this is why I started looking at these, going, hang on a minute, if we can flip these, we can flip the banks around. It really is that simple. And that was where I started looking at this chip here. Now, the pin numbering, I don't know whether you can see from there, it's a little bit crazy. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9. And then here it goes 1, that looks like 2, 3, 4, 5, 6, 7, 8, 9. So of course, I was looking at the CAS 0 and CAS 1 signals here, and I was going across here and looking at the pin number and going, it's pin 7, or it's pin 6, etc. And actually, it doesn't do that. The chip goes 1 to 9, 10, This one's 11, the 1 is missing. There's barely anything there, but there is actually a 1 for the 12, and then there's no 1 before 13, 14, 15, 16, 17, 18, but there is a 1 before 19. So yeah, it's a bad scan or something. All of the 1s on the left hand side of those have more or less disappeared. So that was why when I developed that little socket there to swap a couple of pins here around, when I rotated it around, it just happened to be in exactly the right position for the actual positions because of the way it's numbered, if that makes sense. So I didn't need to redo it a third time. I was able to just flip my little socket around. I could redo it. So I could always indicate something on here, a little white blob or something, just show that's pin 1, or I could just redo it. It's only the cost of a socket, but that was useful in terms of being able to just swap bank 0 and bank 1 around. So we're all cleaned up, we're all tested, it's ready to go back to Yellow Belly. There'll be a link down below to Yellow Belly's channel, do check it out. Thank you very much to him for entrusting me with this. It'll be winging its way back to you today, well tomorrow. I'll box it up today, it'll go back tomorrow, Friday. I do hope you found the video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.